Same instructions on this problem, but we have an absolute value. Just to remind you, we can split up this absolute value into a piecewise function, and I'll do that first before I do anything else. So if I'm looking at this, I'm thinking, for what x values are the absolute values actually effective? So I would say, okay, well, that's just when x minus 1, the inside, is smaller than 0, meaning it's negative. If the inside is negative, then the absolute values turn it back to a positive. So I would just solve this inequality, and I get x less than positive 1. So for any x value that's smaller than positive 1, we would have the absolute values changing it into a negative. So I'm going to write my piecewise function now. F of x equals, if x is smaller than 1, then x minus 1, I could just put a negative out in front of that. That's for x less than 1. And now watch what happens. Let's pick a number that's less than 1. Let's pick 0. If I plug in a 0 here, I would get 0 minus 1, that's negative 1, and out would come a positive 1 because of the absolute value. If I do the same thing here, 0 minus 1 is negative 1, times this negative would be positive 1. So that works out. And then when x is greater than or equal to 1, the absolute values don't matter, so we can just have that. So now I have a piecewise function that represents this absolute value. And so you might be guessing, okay, well, there's a discontinuity at x equals 1. And that's true because we change functions from here to here. So what does that look like? You could just graph this normally. That's fine. What would that look like? That's the absolute value function, but we're moving to the right one, so that would be like this, maybe. Is there a discontinuity? I don't know. I was thinking maybe there was, but maybe not. That's just because they might line up right there, because that's what that graph looks like. But we can see if we take the limit as x approaches positive 1 and see what happens. So if x is approaching positive 1 from the left side, something smaller than 1, we'd have to use this function, which would be negative x plus 1. And then we can just use direct substitution. I plug in 1 here, and I get negative 1 plus 1, that's 0. Okay? And the limit as x approaches positive, or 1 from the right side, well, that means I would have to use this function, which would be x plus 1. Just kidding. X minus 1, right? That's what it is there. And I also get 0. So there actually is no discontinuities. The reason I thought there might be a discontinuity was because it was a piecewise function, but the two functions, this function and this function, they meet up at x equals 1 with a y value of 0. So there's actually no discontinuities here. For any absolute value function, it's a good idea to get a piecewise function and check the limits. If the limits are the same number, then they meet up at that point in question. Or you can graph it and see if it meets up.